Module 9, Acid-Base Chemistry. Identifying acids and bases in chemical reactions. It is time to take what we have learned about acid-base chemistry and use it in some problems. Determine which reactant is the acid and which is the base in the following chemical equation. H2SO4 aqueous plus CaCO3 aqueous produces Ca2 plus aqueous plus HCO3 minus aqueous plus HSO4 minus aqueous. Though there are many substances in this reaction, there are two reactants, hydrogen sulfate and calcium carbonate. If you remember that calcium carbonate is an ionic compound, then you know that it cannot be the acid because by definition, acids are covalent compounds. That means hydrogen sulfate has to be the acid. But if you didn't remember that, you can still figure this out one of two ways. Calcium carbonate will split up into calcium 2 plus ion and a carbonate 2 minus ion like this. Now look at the products. Can you see the calcium ion? Now look at what happened to the carbonate ion. It received a hydrogen and is now HCO3 minus. It accepted a hydrogen plus ion. That means that it is a base. You can also look at the hydrogen sulfate compound on the reactant side. What happened to it on the product side? It is HSO4 minus. That means it lost or donated a hydrogen plus ion, making it our acid. Nothing really happened to the calcium ion here, did it? Chemists call ions like this spectator ions because they don't really do anything in the reaction. They kind of just sit by and watch the others react, like a spectator at a baseball game. So that's how to determine which compound is an acid and which is a base in acid-base reactions. You first need to look at the reactants to see if there are any ionic compounds. If there are, you need to rewrite the equation showing the ionic compound split up into its ions. Then you can better determine which substance lost or gained a hydrogen plus ion. The original compound that donated the hydrogen plus ion is the acid, and the original compound that accepted it will be the base. Let's try another one. Identify the acid and base in the following reaction. HCl aqueous plus NaOH aqueous produces H2O liquid plus NaCl aqueous. Well, first take any ionic compounds and split them up into their individual ions. You may want to refer back to Module 5 to review ionic and covalent bonds, as well as polyatomic ions. Sodium hydroxide, or NaOH, is ionic. The OH is a hydroxide ion, so it splits up into Na plus because sodium is in the 1A column and OH minus. On the product side, water is covalent, but sodium chloride is ionic. It will divide up into a sodium positive ion and a chloride negative ion. Now look at the equation to see if you can figure out where any hydrogen ions went. The sodium ion stayed the same. It is a spectator ion. But the hydrogen chloride molecule lost its hydrogen. That means it really lost a hydrogen plus ion. So hydrogen chloride is our acid. Now, the hydrogen ion is a part of the water molecule on the product side. It attached to the hydroxide ion to make H2O. That means because the hydroxide ion is a part of the original sodium hydroxide molecule, sodium hydroxide is our base. Okay, one more. Determine the acid and base in the following reaction. 2HNO3 aqueous plus MgOH2 aqueous produces MgNO3 2 aqueous plus 2H2O liquid. First, let's figure out which of these compounds is ionic and split them up into their specific ions. There are two of them, MgOH2 or magnesium hydroxide and MgNO3 or magnesium nitrate. Magnesium is in group 2A, so it will have a 2 plus charge. The hydroxide ion has a 1 minus charge. But there are two hydroxides here, aren't there? We know this because of the parentheses and the subscript 2. So we need to put a coefficient of 2 in front of our hydroxide ion. The magnesium and the nitrate also will split up, the nitrate having a 1 minus charge and there being two of them also. Returning to the equation, we can see where the hydrogen plus ions went. Notice again that water was made. That means that the hydroxide ions each took on a hydrogen plus ion. Hydroxide was a part of the magnesium hydroxide molecule, so that is our base. Where did the hydrogen plus ions come from? The two hydrogen nitrate molecules. That is why in the products we see two nitrates. So hydrogen nitrate, commonly called nitric acid, is our acid.